Friends, we will be discussing about two simultaneous reactions going on and how the metal balance is impacted by when the reactions are going on, right, with the known feed composition. So the reaction is between methane and steam, and consequently the carbon monoxide which is being produced further reacts with steam to produce carbon monoxide and carbon dioxide and hydrogen. So total 4 moles of hydrogens are getting generated from 1 mole of methane and 2 moles of steam. The feed enters at 350 degrees Celsius at a pressure of 30 with 2110 mole per second of the flow rate. Feed compositions are given, and we are assuming 100% conversion of methane and carbon monoxide. When neglecting the pressure drop, so what are we supposed to calculate is the flow rate of the outlet stream, right? This can be done with hand calculation or can be done with the help of the uh, simulator like CHEMCAD. So we see that how do we do that in CHEMCAD. So I already defined the feed, which is 350, 300, 30 atmosphere, and the corresponding the mole fractions. I take the equilibrium reactor and I connect it to this. Then I take the product and I connect it to this, and I open the reactor. So in reactor, I know that there are two reactions going on. I'll not assume any pressure drop. I will consider this to be an isothermal reactor taking place at 350 based on the data provided. The reactions are going to be parallel reaction in nature, and the reaction phase will be vapor phase. It's very important to click this radio button. Otherwise, the reaction will not happen. I'll press OK. Then I'll go to the adding reactions document. It is mentioned that methane and carbon dioxide are going to be 100% converted. So we'll write methane. So reaction is between methane, steam generating hydrogen and carbon monoxide. So this is -1, 3 and 1, and the fractional conversion is 1. So we specify this much information, and we go ahead to the next reaction. So in next reaction, carbon monoxide is the base component. So I'll have carbon monoxide, steam, carbon dioxide and hydrogen. So this is -1, -1, 1, 1. Just to reconfirm, let us check it. 1, 1, -1, -1, 1, 1. Okay. And for that also the fraction conversion is 1 or 100%. I press OK. So I'm ready with the setup. I just select this, run selected, and what I'll get here is this. So my methane is completely consumed, right? And my carbon monoxide is consumed, but it is also being produced from methane. So if I go with the mole fractions, my mole fractions would be like this. My hydrogen is almost 60%, and this is something which I have got as an outlet. Now if I want to see parameters, then I can just make those changes here in the feed, right? We can make some feed change here, and we can run it. So like I can make changes in the conversion. Say for example, this I'll make 0.8 or 0.9, and I'll keep and I'll see what changes it shows. So it will show the lesser amount of conversion to hydrogen. So since it is an equilibrium reactor, right, and we are going to talk about this particular reaction. So the final outcome will depend on the equilibrium data, which will change with respect to various parameters, which we may see by varying the parameters. But this is how we can run a multi-reaction problem in CHEMCAD, wherein more than one reactions can take place simultaneously. I hope this will clear the idea about metal balance for simultaneous reactions, as well as how to solve the same in a process simulator like CHEMCAD. Thank you.